right. Hi, everyone, and welcome to the quest for SBOMs and the legend of the SBOM'd Substation. I'm Matt. I'll be the host of this game today. I'll be narrating, and we also have Alex.
Yeah, good afternoon, and I'll walk you through the gameplay and the real-life intricacies of SBOM'ing a substation.
We're excited to walk you through this journey with all sorts of twists and turns and fun adventures that we got to experience firsthand over the last year.
Yeah, and I'll share some insights on the strategies developed and some of the roadblocks and hurdles that we uncovered along the way.
And before we go any further, if you're asking yourselves, did we actually create a whole set of original video game art to describe the process of collecting SBOMs for a substation? The answer is yes, we absolutely did. So let's get this started. To frame this, we need to go back in time 1 year to this exact location at S4X23 when we hosted a roundtable discussion. We brought together asset owners, OT equipment suppliers, security vendors, and government stakeholders with just a discussion prompt. We've been talking about SBOMs for a long time, but is anyone actually doing anything with them? How do we operationalize this? And we left that room with some really interesting insights and a challenge, a mission, if you will, for our player here, Alex. The mission was simple. We need to SBOM a substation. We picked one in Mississippi, and we knew a little. We knew that there was stuff in it, and we wanted to get SBOMs for the stuff and do things with it. And with that, you have your mission.
So I will be perfectly frank that I had no idea how daunting of a task this was. You can ask quite a few people that heard me lament on the struggles that we were facing. But, you know, armed with Dragos and OT network visibility, some of our existing asset inventory databases, some PPE, and a camera, we actually went through and tried to do our best to get an SBOM for every device in our substation.
Well, let's get started. Let's jump into this world that we're going to be navigating. So we started off on this very, very simple, ideal quest for the SBOM. We started off with this perfect asset inventory that everyone obviously has laying around. It has all of your devices, your software versions, everything ready to go in one place. So we were just going to start there. Sounded good. And then from there, we just ask. We just ask the vendors for the SBOMs. They give them to you on a silver platter, right?
Yep. Please is the magic word, right?
And from there, we take those SBOMs and we drop them into the magic machine that interprets them and gives us all of the insights that we want.
Yep. And then we get the magic vulnerability eraser, where all we have to do is click a button, poof, we're secure.
And in the end, vendors and asset owners, engineers on both sides are walking hand in hand, securing the substation together, all singing in harmony. Well, let's come back to the real world for a second. And while this map of the game looked really great and enticing, it turns out that we were actually looking at something that was a bit more like this. So this is a bit more foreboding. It's a little less Candyland and a bit more Jumanji.
Yeah, you know, navigating through Vendor Valley and the trials and tribulations of the inventory jungle, we really started to realize it's difficult not just to make sure you have a proper understanding of the what you need, but also how to get it, how to process it, and how to analyze it.
And there's a lot of twists and turns here. Mm-hmm. You know, there were some opportunities to take a wrong turn and, you know, wind up at internal politics point and accidentally fall into the abyss.
Hopefully you don't fall in that false positive fjord.
Yeah. Lots of traps here. Well, let's go ahead and get started, and we're off to level 1, the inventory jungle. Welcome to level 1, where knowledge is power and seeing is believing.
Yep. So as I said, you know, we started with our network visibility tools and the inventory that we had in there. And then we cross-reference that with known asset repositories. But the one thing that was missing there was software versions, right? We had no idea what version of software we were running from an inventory perspective. We had some insights in some locations, but we also had multiple business partners and business units that managed different parts of the pieces in the substation. And as you see our network segments in a later slide, you'll start to understand really how many different people are involved in the devices that go into a substation.
So in short, an inventory that you need in order to do this, to solve this problem, SBOMs and software supply chain security, is a bit more detailed and challenging than just a traditional inventory problem.
Yeah, so after a really good lunch at the shed, we went into the substation. We walked it down. We took pictures. We called our friends. We called the folks for physical security devices. We called our condition-based maintenance teams, and we tried to not just uncover the devices and the hardware model, but also, like I said, the firmware versions, to make sure that we were actually getting SBOMs that meant something to us.
Well, let's see how this level concludes. So in the end, the inventory jungle actually was bearing some fruit, and the prize was a map.
Yeah, so we ended up with 38 total devices across 16 different vendors in our different network segments. Our control network, which just like it sounds, it controls the physical process alone, had 18 different devices. Then we had our OT monitor and our OT fault, physical security, cybersecurity, and telecommunications. And all of these together, again, gave us what we had to start with.
So we were able to accomplish that first task, and that takes us on to level 2, a little bit more foreboding, the level we call Vendor Valley. It's a dicey negotiation full of challenges and opportunities and people that were maybe unexpected.
Yeah, and the journey through Vendor Valley itself is probably fraught with as many differences as the vendors in the substation, right? We had some vendors opening or welcoming us with open arms, you know, trying to give us SBOMs, like, here's some candy, little boy, right? And then we had other vendors that were really kind of shrouded in the mist of legal layer. So it was really interesting learning how much direct interaction you really need with your vendors to be able to make this happen.
And there were a lot of iterations. You got to play this level a whole lot of times over and over and over again, going roundabout and roundabout. After a while, your health was starting to look a little low in this level, but nevertheless, we got through it.
Yeah, Matt did pull me off the politics point ledge once or twice, so
That's
we had some fun.
Yeah, it's really important not to jump from there. And like any good saga, this one also has some side quests. So in side quest number 1, there was a bit of drama about the way that you were requesting some of these SBOMs, right?
Yeah, so this is an actual email from one of our vendors. And it basically states that any firmware released prior to the Biden executive order requiring critical infrastructure security enhancements would be denied because they're not going back in time to create SBOMs. But we're OT, right? We move at the speed of snails. I can't guarantee that all of my firmware is up to date. I really can't. I don't think there's any way to keep that many systems in your critical path, especially when they can't be replaced sometimes.
You didn't just want to update them all?
Yeah, I wish I could.
So this is really important though, and this is a really, I think, a unique aspect of SBOMs and software supply chain security in OT and how it's different from IT. Because in the IT world, as SBOMs are starting to take hold, it's easy to say, we're going to start building SBOMs as a vendor, as a supplier. We're going to start doing that with the next version, and we don't have to worry about anything before. But the challenge for OT equipment manufacturers is you actually have to be compliant to give your customers what they need. You may have to go back 5 years, and you have to have an SBOM for every version of your software so that Alex has the one for the one that he has in his substation, and likewise from substation to substation, from facility to facility. That's a challenge in OT that you don't find as much in IT.
Right, and I really figured that, you know, the code from 5 years ago and the code from today, while there's gonna be differences, right? They still maintain that repo if they still publish the code and they still give it to their customers. So we really thought that was one of the, we'll call it, more interesting side quests that we hit early on.
And you were having so much fun in Vendor Valley that you decided you wanted to go on a second side quest, is that right? And in this one, it turns out that even with SBOMs and that were glittering very nicely, it turns out that not all that glitters is gold, that there are some restrictions that made even the most well-versed players pause for a moment.
Right, so, you know, I think I took for granted access to vulnerability databases that are cloud hosted. I took for granted how some of the tools, whether they're open source or you know, like finite state, how they leverage repositories of vulnerabilities that are constantly changing. And in this case, I had to pull down 14 gigabytes of vulnerability database to run a point-in-time assessment on an SBOM, which is not sustainable. It's not something that we can operationalize. We have to leverage some of the tools at our disposal. We have to leverage the ability to use external resources and analyze this stuff so we're not just maintaining our own vulnerability database, right? They exist everywhere. There's 10 of them, I think, that are free to use that you can run a bunch of scripts against. But if you don't have the ability to do that, you know, you're kind of hamstrung. And then the value of those SBOMs starts to diminish because you can't track unless you're manually updating and figuring this out.
And this is important. This is challenging. Right now, SBOM sharing is clunky. There's a lot of people involved. We're going to talk more about it. But the key is just collecting SBOMs in and of itself. If you can't do anything with that data, those SBOMs are just JSON documents that sit in a folder, and you've checked a box, but you're not actually getting any benefit from them.
Yeah, that's true.
So with that side quest behind us, we wrap up level 2, and we can look at a few gameplay statistics here. So the data is interesting, and it tells quite a story. You know, just as a starting point, on average, it took 60 days from a request to receive an SBOM.
Yeah, that's right. And again, that's an average over the SBOMs that we actually got, is from request to receipt was about 60 days, which in several cases, we were updating firmware by the time that we were receiving that SBOM. So then the value of that SBOM is now gone because you're on new code. And even though we did not receive, we actually got no, we will not give you SBOMs for 58% of the SBOMs we requested. That's a lot. That's a big failure rate. But all of those no's led to some yeses, right? It really sharpened our resolve to figure this out, because if this is so hard, this is the type of complex problem that we really need to work together on.
And while there were a lot of challenges, a lot of obstacles that you had to overcome, I think what we saw was that each time you did it, it got a little easier. It sometimes would take it took 12 meetings on average to get it, but the next time you asked for an SBOM from that vendor, a lot easier to get it.
Usually, yes.
Yeah. And so while, again, the health was low going through this particular level, you survived, and we're on to the next.
Yep.
With that, we wind up in level 3, the SBOM enigma, where we ask ourselves, now that we have this trove of SBOMs at our disposal, what do we do with it? How do we decipher these enigmas?
Yeah, it's almost like we had a whole bunch of ancient scrolls written in cuneiform. And each SBOM was really a part of the Rosetta Stone. And trying to understand the complexities of SBOMs and the requirements of SBOMs and the data needed to provide a healthy SBOM was very interesting. I mean, there was a whole lot of manual analysis of these SBOMs, well, scripted analysis of the SBOMs prior to even uploading them into the finite state platform, just to make sure that they were good, that they had the data we wanted, that they had the proper component data. They weren't just a list of things in a JSON blob, right? We wanted some of that additional context.
And so, what we're talking about here is there's two major formats for SBOMs. There's CycloneDX and SPDX, simple enough. But each of those has a lot of versions. They've been under development for a long time. And then it's not the format of the SBOM that's important. That's easy to conform with. It's a question of the data inside of it. There's a lot of subjectivity and opportunity when it comes to, for example, which software identifiers you put in there. If you pick the wrong one, if you have a typo, everything gets off kilter, and it's hard to automatically assess that. There are tools that can help you, though, right?
Mm-hmm. Yeah, so we took a random selection of our SBOMs, and we ran them against the SBOM quality score. And we saw that in many cases, they were barely passing, right? Much of the SBOMs did not just, they didn't meet the NTIA minimum requirements. They didn't have a lot of the component data. They didn't have a lot of the dependency data. And it really made us pause and reevaluate and really try to make sure that we're not just trying to operationalize SBOMs, but we want to make it better. We want to help. This needs to be better, right? And there's a whole lot of people. We've got finite state, we've got community-driven projects through CISA and other things that are really trying to help. And I think there's a lot of good work here. And we're barely passing right now.
But the good news is, over the course of the year-long journey, everything got better. The quality was getting better. Each time you went and asked for one, it got better. The standards are getting better. And so there is hope despite the challenges that we had. And with that, we leave level 3, having deciphered many of these SBOMs and understanding the quality, and we head over to level 4, where we find ourselves in firmware forest, where in this case, we want to go verify, after we've assessed the quality, is it correct? Did the vendor give you all of the components that are actually present, or were they missing things?
That's right. And again, there was a little bit of automated and scripted analysis here. We did have the benefit of receiving some unencrypted firmware from one of our vendors. And we ran that through finite state as well. And we actually found differences. We found that the SBOM had, what was it, an average of 72 less components than the firmware analysis. And Matt's a whole lot more technical in the reason why, but that to me, that's an issue, right? And it's not the fault, and it's not that one SBOM was bad because it didn't have this other stuff. It was just pulled at a different level and probably lost some of its dependencies.
Exactly. So it's not abnormal to have SBOMs that look different, because you can generate an SBOM at different times in the build process. You can do it early while the code's being written. You can do it build time. You can do it post-build with binary analysis. Each of those is going to look different. That's okay as long as all of the components are there. And in some cases, we saw that a lot of dependencies were not making their way all the way over to you, which means you don't know about some of the software that's actually in that device. And that's what we want to avoid. And that's why independent verification and testing is important, because it allows you to go back to the vendor and talk about that and help them get the tooling in place that they need to be able to accurately generate all of those dependencies.
That's exactly right, Matt. And it's really a us thing, right? It's a relationship building thing. It's something where you have to have open, honest, and sometimes hard conversations to really try to turn this around.
All right, so that concludes level 4, and we're feeling pretty good. We've made some progress. Your health is getting really high right now. We're getting ready. We're going to turn the corner, and what do we find? The vulnerability horde.
Yeah, so armed with a heads-up display, we started analyzing our bug bots. And we started trying to weed through which are good, which are bad, which ones need to be prioritized, which are the CVEs in open source code that can actually take down a system. And manual analysis for this is hard. It takes a full-time vulnerability research team to try to weed through a lot of this stuff. Luckily, we were, with a limited number of devices. But this is a real, set of numbers from some of our SBOMs on the number of vulnerabilities. That's a lot.
So you're saying you didn't want to work through 16,000 vulnerabilities on your own without some extra data and intelligence to help you along the way? You were going to stomp on all the little green ones. Yep. Until your feet were gone?
Yeah, so we brought in some additional teams for threat and vulnerability research, independent testers, and we started to understand that this sensational number of vulnerabilities really wasn't that big.
And so it was important to focus on the big ones, the important ones, the exploitable ones, the ones that you knew that threat actors were targeting, the big bosses up there that are flying around that are bright red.
Yep, that's right.
But nevertheless, this was daunting, and you didn't really want to keep going through it, right? So let's wrap up level 5 and see what's around the corner in level 6 here.
Let's do it.
Oh, and we find ourselves in exploitability enclave with a friendly wizard who trains you in the magical ways of Vex.
Yeah, so we were armed with our shield of Vex, right? And as the Vulnera drones were circling the castle, we were actually able to start processing them based on the vendor-provided Vex analysis. And we started to prioritize which vulnerabilities were important. And we no longer had to figure it out. We worked on we're going to trust our vendor, and we're going to trust what they say in this Vex document as a starting point. And we found that we're reducing the number of vulnerabilities by 99%. One system had almost 3,000 reported vulnerabilities in its open source software. And the Vex provided by the vendor showed that only 7 were of importance to us.
So we have a cheat code here. We can reduce vulnerabilities by 99%. It seems obvious, easy. We just have the vendors do the exploitability analysis, give you the Vex document, no problem, we're good.
But it's a trust thing, right? Cybersecurity is about trust but verify. And in this case, we worked on the trust of our vendors and their Vex analysis. But when you're using your vendor's word as law, you really need to hope that the law is righteous. Otherwise, you can find yourself in some pretty bad spots.
And that takes us to our next side quest, where we need to determine whether the Vex data is true or not. Mm-hmm. And in one case, you had a vendor that asserted that a vulnerability was not exploitable, but you found otherwise, right?
That's correct. Through some independent analysis, we actually found that a vulnerability that was reported as mitigated was vulnerable, accessible, and there were public vulnerability exploits that were on the interwebs for us to use to have fun with it.
And look, this is not to roast vendors, because we work with more vendors than we do asset owners. This is a hard problem. Exploitability analysis is hard. It's hard to do at scale. It's hard to do accurately. It's just why it's important that there are multiple checks and testing points and collaboration that's happening in the process. It's too valuable to ignore.
Verification and validation.
Yep.
Right? We've got to apply here the same principles that we apply in other places, right? Checks and balances, trust but verify, all of those things come into play here through vulnerability exploitability analysis.
And with that side quest, our journey is over. We have wrapped up the quest for SBOMs for this time, and we have some insights. We were able to get through this and use it, and we learned a lot, right?
Yeah. Through this process, I started to think, how can a utility operationalize SBOMs? What are the things that we can do through VEX analysis, verification, to really operationalize SBOM analysis, right? We don't want just another database of components. Sure, that's great to answer, the fire drills of do we have. I like those types of things that make my job easy. But if I were to start thinking about how could we really use VEX and SBOMs to reduce O&M, I think of prioritized vulnerability management and really understanding our existing mitigations, whether or not a system is vulnerable and exploitable, and how do we prioritize that patch.
And look, whenever you go through something that's a little challenging, it's new, uncharted, it's important to take a step back and think about where we were before we started this. Before we started it, you did not even have a centralized inventory of all of the equipment and software in this substation. There were no SBOMs for any of the stuff whatsoever. You didn't have any insight into the vulnerabilities that were coming in from the supply chain at all, even though you had to wade through a lot of them. You didn't have relationships with a lot of these suppliers that where you started working with their security teams, and now you have open channels of communication.
Yep.
And so there's a lot of wins in there, even though we didn't hit the metrics we wanted.
Yeah.
We made a lot of progress.
Yeah.
But let's look at those metrics. So let's look at these gameplay statistics. The statistics are interesting, and let's go ahead and get started. So the first one that, again, we've talked about a few times is how long did it take to get an SBOM?
Average of 60 days from request to receipt.
It's a long time, but it's getting shorter. Each time it was getting shorter and shorter and shorter. And another one that's really interesting, a Linux-based system has had over 1,800 different components in an SBOM on average. That's a lot. It's like looking for needles in a stack of needles, yeah.
Well, and polite persistence too, right? 12 emails and/or meetings with vendors just to try to request and receive SBOMs. That's also a lot of time and a lot of effort.
And so, while there's a lot of really good data that here, the technical aspects of this are really interesting, but like any game, the real question is the people.
Yep.
And there were a lot of people involved, right?
Yeah, I commend Matt for this slide. I love this slide because it doesn't just show the people at Southern that were involved in getting the SBOMs. It also shows the vendors and the side of the vendors that we had to engage with to get SBOMs and to make sure that we were working within their processes and we were trying to partner through this. We also had a lot of support from our vendor risk management team in helping with those lines of communication and really helping us along the way.
And this is important because when we talk about the average time to get an SBOM, the amount of meetings that were required, it was about building a coalition of these folks who all are stakeholders in the process. And that's why the first time was harder. But once everyone started to get engaged, it got a whole lot easier.
Yep, that's right.
And that concludes the quest for SBOM, but we can't help but preview what's coming next. So we do have another stage. The game is over, level 1 is over, but we're not done. There's a future here still. So I'm very excited to talk about a program that we're going to be working on with Southern, and we have some new players who are entering the game for the next phase of this. We have EPRI and Schneider Electric and Scythe and Ameren and MITRE all working together under a DOE program that we're going to be executing over the next 2 years to automate a lot of the pieces of this, because what we found was there's a process here that we built that works. The inventory, SBOM collection, verification, vulnerability enrichment, VEX exploitability analysis, all the way through operationalization, right?
Yeah, and I think that Southern Company is really ready based on the information received from this year and this journey to continue moving forward. and to really try to help solve the hard problems and try to figure this out because, as I said, it takes a village.
And we can see, look, the bottleneck, if you listen to the story and think about it, the bottleneck is that exploitability analysis. It's the most powerful piece of this. It's also the most challenging, and it's the one that needs to be done at scale to allow this to really unfold at a scale that the entire Southern enterprise can use. So we're really excited about the R&D we're going to be doing, and hopefully next year we'll be able to talk more about that in the sequel.
Thank you.
Thank you all.